Welcome to Section 5, Visualizing Your Data. In this section, we'll make reports and dashboards that produce cool visualizations for your Splunk data. Let's get started. Welcome to data models. The concept of a data model is quite simple, but data models themselves can get kind of tricky. That's okay, we'll walk you through them. In general, a data model makes machine data easier to use. It simplifies complex data through abstraction, and it groups specific types of data. What do we mean by that? Well, your DevOps group or your operational intelligence group may not know everything that you know about Splunk. So what you can do is build data models for them so that they can still create visualizations, alerts, and reports in Splunk, but without having to know the nitty-gritty details of Splunk like you do. We actually use data models more often than we think. For example, mathematical formulas are a perfect example of data models. Remember, the formula to find an area of a triangle is area equals 1/2 base times height. And think about it. The data can be totally different for A, B, and H, but the model is how we make sense of the data. We can put in any number for 2 of those 3 variables and solve for the third one, for example. So a data model really is the set of rules that governs how we interact with the data and how the data behaves. It's kind of like stacking Legos in the Splunk world. We stack objects, object constraints, and object attributes, i.e. fields. Objects contain events, searches, and transactions, each with their own proper constraints. And then we add fields, auto-generated from the Splunk engine, lookup tables, eval statements, regular expressions. Let's take a look at objects more closely. Events are the most commonly used type of object. And usually events represent the very first part of a search, i.e. the metadata, also i.e. host equals source type equals. It's a very broad place to start, and that's good. Searches are more complex than events in that they can contain commands and transformations and things like that. And transactions can combine multiple events from one or many sources into a single event. And now let's take a look at fields. Also object attributes in the data modeling world. They're not tied to a specific object. We can get auto-extracted fields, eval statements, lookup tables, or regular expressions. Data models are extremely powerful in Splunk. And the idea is to have a dedicated team of people that just builds and defines data models for the operational intelligence people. And the operational intelligence people will then use the Splunk pivot tool to build visualizations, alerts, and reports based on the data model that you've already built for them. So you build the underlying structure, the data may change, the rules that govern that data are embedded in your model and ready for the operational intelligence people to use. So let's take a look at building a simple data model in Splunk. To create a data model, on our Splunk search head, we'll go to Settings, Data Models, and we will choose New Data Model. We'll call it something. We'll choose an app context. Doesn't matter too much. I like to go with searching and reporting. Click Create. And now it's going to ask us to start building with those Legos, to start putting in our data sets and our constraints. So first of all, it says to get started, add a data set. Now recall we can start with a root event or a root search. An event is simpler than a search, and usually it's broader than a search, meaning we could do a broad search like host equals or source type equals. And I think it's good to start with that. And let's name our data set my dataset 1, and this is the constraints box, and that is where we will put our search. And we know that we have the homework dataset already uploaded into this Splunk instance, and the host value is set to homework. I can click preview here and see that. And there's our homework dataset. So let's save that, and notice it put that dataset here as one of the building blocks for this data model. And it gave us the original Splunk metadata fields of time, host, source, and source type, and we can add more fields as necessary. But now let's think about the use case for this data model. Let's say that our operational intelligence analysts want a data model that they can put data in and manipulate that deals with backup volume and backup duration. So as the Splunk administrator, or as the data professional in the organization, to build this data model, those are the fields that we want to add, the fields that we believe the analysts will need in this data model. So because this is just a CSV file, all of the fields have been auto-extracted, but we can use an eval expression or a lookup or a regular expression to get the fields that we need. But we already know the fields are auto-extracted. So for backups, I think it's safe to say we would need these two fields. We can look at a sample of the data of any field we're unsure about. Let's include date. And maybe destination IP is important. Let's look at event type. Okay, nothing there. Level. If that relates to backup error messages, then that would be good to include. Physical address looks like machine MAC addresses. The analyst may need that information. Source IP would be good because we have destination IP up here as well. They might need to know what state and the system ID, and we won't worry about these time ones because we can just use the default _time. And type probably has something to do with it as well. Now we can force these columns, these fields, to have different data types, but generally speaking, Splunk selects the best data type for you. Okay, here's our current data model. We can make a more complicated data model if we had more data sets to work with that would be relevant to this data model. In other words, relevant to analyzing backup data. We could add children and other root events as well. So you can see how we build this data model in a hierarchical way. In the next video, we'll look at how to use this data model by accessing the pivot editor right here. So until then, keep splunking, and I really appreciate you staying with me in this course. Welcome to working with the pivot editor. This video is a direct sequel to the last video, so I recommend you watch the last video if you haven't already. Where we left off was we created a basic data set, and the pivot editor works with data sets. Datasets are created by the data managers in the organization, and they are the rules and constraints which govern data, and they allow analysts to use the pivot editor to build visualizations based on those datasets. Here we've built a very simple dataset that has host equals homework, and then it includes all of these fields. If we simply click on pivot to enter the pivot editor, it will ask us to select the data set that we want to work with. There's only one data set, it's the one we created. When we first enter the pivot editor, you'll notice that we have some default values already preset. In the filters area, we have all time, and in the column values, we already have one column value that's count of all events in the data set. These are the things we manipulate in the pivot editor to build our statistical table and eventually to build our visualization, which we'll select from the left side here. The filter area is used to reduce the result count for the data set. For example, I could do a filter of only the last 30 days or something like that, and that would reduce the result count. You can imagine if you're working with huge data sets, filtering those data sets would be extremely important. Time is essential as a first filter for any data set, but we can add other filters as well that will reduce this data set. And notice that only the fields that we selected to be in our data model are here. So you can imagine that by doing this, we make the analyst's job a lot easier. Here we have split rows, and what this does is splits out the pivot results by row. For example, we could have a row that represents a particular date and time. We could have a row for each month, or a row for each week, etc. We can also split the values by column. But be careful with splitting values by column. Column values are almost always numeric in nature. There's some sort of count or sum or average. So let's start working with our data set. First of all, let's constrain this by time. And let's choose a relative timestamp, and we'll go to 120 days ago and apply that. Now we've filtered this down to only 205 events. And now remember we're pretending that we are the data analysts now. So we want to find out specific backup data, and we want to build a report on that. So let's add a row for time. And what period do we want? Let's say days will work, and we'll do the default sort. Now we have one row per day, so that's what split rows means. We still have the default column value of count of all events, so this is counting all events on that day. But that's not really going to help us in our analysis of the backup data, so let's click on this and change it to backup volume. Give it a friendly name. And notice here that we can do different kinds of calculations. This is assuming that it's a numerical value. And there's only distinct values in the data set, so we can do sum will be fine. It's going to sum it up per day. Backup volume. Awesome. Now we might also want to know a source IP address, for example. And we can manipulate these if we wanted to. We could simply drag and drop the rows around. But I think we have a good amount of data to build a very basic visualization. So I'm envisioning a line chart or an area chart with time on the x-axis and volume on the y-axis, and then colored by the source IP. Let's see if we can do that, and I think maybe we'll try an area chart. And right now time is on the x-axis and volume is on the y-axis. So let's scroll down to colors, add color, and the color should be the source IP. And let's see what that does. Okay, now this could be useful. The data in the data set generates a random source IP, but if we assume that we only have a distinct set of systems, then this could be a really valuable area chart. So let's make this zoom in just a little bit, and in the time range, let's do a date range. And we'll do April 1st to April 30th, 1 month. There are way too many source IPs here, so Let's instead change the color to something that has discrete values and not as much. Maybe level. Now this is a much better chart because we can see the date, we can see the volume on the y-axis, and then we can see that it's colored by level, so maybe error level or something like that. That's the area chart. We can see if a different chart might work better for us. Maybe a line chart. And as you can see on this, where there is no data, it is not connecting them. We can change that simply by clicking this here under General, where it says no values. We simply connect. It makes it look a lot better. And we can maybe see what a bar chart would look like. Pretty busy there though on a bar chart. What about a column chart? Again, this could be useful. I think maybe if we do a stacked, there, that's really actually quite nice.